So guys, today we are going to learn about minimum depth of the binary tree Leetcode problem 111. So here we are given a binary tree. We need to find its minimum depth actually, not the maximum. The minimum depth is the number of nodes along the shortest path from the root node to the nearest leaf node. So in example, if you can see here, a definition is given like a leaf node is a node with no children, like both left and right are null. So here in example, we can see there is a root node with 3, then its left children is 9, its right is 20, then left node of 20 is 15, and right node of 20 is 7. So here, if we can observe from the root, if you traverse, we can see that 9 is the children leaf node. 9 is one leaf node, which is at a distance of 1, actually depth of 1. Okay, and since here depth is calculated not from 0 but from 1, so root node is considered as at a depth of 1, so 9 would be at depth of 2, so 1 plus 1 basically 2. And if you can go for other leaf node like 15, we can see that 15 is like if we traverse, it would be from 3 to 20, then 15, so it is at level 3 is considered to be at level 1, 20 to the level 2, and 15 at the level of 3. So 15 is at the level of 3, and 7 is also a leaf node, and its distance is again 3, which is similar to the depth of the 15 node. Yeah, but we need to calculate the minimum, so minimum is 9, 1. Okay, just 9. Yeah, so let's go and look into the constraint is like node value can vary from -1000 to 1000. Okay, and the nodes in the tree are range of 10 to the power 5, which is 1 lakh, I think. Okay, so let's try. This looks like, since we need to traverse and we need to calculate the depth, so we need to traverse from top to bottom. So it's a top to bottom in a level order traversal, so it's kind of if we can go using BFS, it can be solved. So here let's try with BFS. I have created a simple method BFS and general BFS leaf node level, basically leaf node level, which is we need to find the shortest one. So yeah, if you can see simple logic of the same binary breadth-first search, actually BFS, the same logic, like we take a queue, so a simple queue is taken here, and it is saying like if root is equal to null, return 0. Okay, if there is no root or no nodes in the tree, it is considered to be empty, so we can return 0. And if it is not empty, then we will proceed further, and what we do, we offer basically add the root to the queue. And okay, now we have a depth variable which is I am considering to be 0, but here it is at the root node is considered at level 1, so while returning we will add 1 to the depth of the tree on that node. Okay, so let's proceed for the standard BFS standard BFS logic, like while we take a while loop, while queue is not empty, we can keep the size of the queue into a variable n, and now we go for the for loop, basically to iterate through the nodes in the queue one by level. So I is equal to 0, I less than n, and then I plus plus current node q dot for, and here if you can see, we need to check if it is a leaf node. So we can see current dot left is equal to null and current dot right is equal to null. So simply we are returning depth plus 1. Otherwise, what we have to do, simply we have to push the left and right children of the current node. So if current dot left is not equal to null, we are offering it to the queue. Similarly, for current.write, we are returning. If it is not null, we are offering it to the queue. Basically, we are adding into the queue. Okay, so this for loop goes on. Once the for loop exited, like after one level is finished, by basically level by level, we have to increase the depth, because after each level, if for loop exits, then we have traversed the one level, so we are going to increase the depth plus plus. Okay, level by level traversal. Now depth plus plus we are doing simply. Okay, yeah, in the end what we have to do, we are closing our while loop. After while loop, we simply return the depth. Okay, so let's run and see what we can see. It should be running. Yeah, it is accepted. You can see both the cases, expected 2, and in the second case is 5. Let's submit it. I have already done this. Yeah, bits around 93.99%. So yeah, BFS solution is working. Okay.